Math 3, Lesson Summary Video, Footprints in the Sand. This lesson is a Solidify Understanding task, which takes concepts developed previously and helps you formalize those ideas. The purpose of this lesson is to deepen your understanding of the volume formulas for prisms, pyramids, cylinders, and cones. We're going to start today by adding to our vocabulary. When we're dealing with a pyramid, you want to make sure that you realize a pyramid can have any polygon base and then triangles for each side of that base that connect at one point. When we are talking about pyramids, you do want to realize that there are two different heights. One height is the vertical height, and as the name would indicate, it does have to be perpendicular to the base and go straight up to that point where all the triangles connect. Another height on a pyramid is what we call the slant height. And it goes from the point where all the triangles meet and goes down the triangle on the side and is perpendicular to that base edge. If you have a cone, similar with cylinders and prisms, it's the same concept as a pyramid, but its base shape is not a polygon, it is a circle. And so it does have the same height. We have a vertical height, and then we also have a slanted height. So the vertical height still has to go from the top point perpendicular to the base, and the slanted height has to go from the point to a point on the circle. And so the slanted height, I always tell my students, is like sliding down the side of the pyramid. And the vertical height is if you took the elevator down to the bottom. So pyramids and cones both have two different types of heights that we use in different situations. It's important to notice that the relationship between those two heights has to do with the radius of the circle, or in this case, the distance from the center of that base polygon to the midpoint of the triangle, the edge there. It makes a right triangle. So if we know one of the heights and we know the radius of our circle, or half the distance, half the length of our edge, then we're able to use the Pythagorean theorem to help us find the piece that we're missing. That will be an important skill that you'll want to make sure that you go back and remember. So very rarely do they give you both of those heights. I won't say never, but usually we do end up using the Pythagorean theorem to help us find one of those heights. And our last vocabulary shape that we want to discuss is a sphere. Now, a sphere only has one dimension, a radius. This sphere is the collection of all points equidistant from a single point in three-dimensional plane space. So there is only one dimension, and that is the radius. You can take it all the way through and get a diameter, just like you can with a circle, but everything for a sphere is really based off of that singular distance, that radius from a central. So let's discuss some formulas. When we're doing the volume of a pyramid or a cone, just like cylinders and prisms, they can use the same volume formula. What it's really based on is the area of that base. If that base is a polygon, you need to find the area of that base. If it's a circle, you need to find the area of that base. It is also important to note that when you're finding the volume of a pyramid, the height that we need to use is the vertical height. So if you're not given the vertical height, but you're given the slanted height, make sure that you find the vertical height. For volume, it does have to be the vertical height. Now for surface area, I do want to talk about the big rule of surface area is always take the area of all of the faces and find their area and add them up to find the surface area of a three-dimensional shape. And for most pyramids, that's what you have to do. If you have a regular pyramid, now to be a regular pyramid means that the base shape has to be regular. And in geometry, regular has a very specific meaning that all the sides and all the angles are equal. If you have a regular polygon for your base, or if it's a cone and your base is a circle, then you can use this formula to find surface area. It allows us to find that lateral area a little bit easier. But if it's not a regular pyramid, then you are going to have to find the area of the base and the area of your triangles around the side and add it up. I do want to point out that in the surface area formula, however, you do want to use the slanted height and not the vertical height. Because again, we're talking about the surface area, we're talking about those triangles on the side. So we're really interested in the heights of those triangles, not the height of the pyramid. So the slanted height is the height of the triangles, not the height of the pyramid. So for surface area and volume, for cones and pyramids, we have these two formulas. For a sphere, please note, we only have one dimension in a sphere. So our formula can only use radius. That's our only option because that's our only dimension. To find the surface area, just the wrapped around area of the sphere, it's 4 times pi r squared. It's area, so it's still a squared dimension. So 4 pi r squared. To find the volume, volume is a cubed dimension. So we have r cubed, and it's 4/3 pi r cubed. So that would help you to find the volume of a sphere.